All right, welcome back. We are going to talk about section 4.2. And our main topic here is absolute value. Now, absolute value is a pretty simple concept and it's not that tricky, so I think we'll get it pretty quick. But we have two new terms that we're going to talk about. The first one is the opposite, and the second is, of course, absolute value. If we take the opposite of something, this might ring a bell at some point. But if I take the number 9 and I take the opposite of it, I'm going to end up with negative 9. And if I take the number negative 5 and I take the opposite of it, I'm going to end up with 5. All I do when I take the opposite of something, if I look at it on a number line, is I move from where it's positive, I take the number 2, and I just swing it over to where it would be in the negative number line. So all I do is I take it from negative to positive or positive to negative. Pretty simple. Now, if I'm taking the absolute value of something, I can take the absolute value of 9, and I can take the absolute value of negative 5. And when I write absolute value, I get to put these like weird just line brackets on the side of something. And this is not something we use often in math, but it does come up every once in a while, so it's important to remember. And when we use it in functions and things like that later, it makes some interesting things on the coordinate plane. But when we take the absolute value of something, all we do is we take it and we make it positive. So if it's positive, stays the same. If it's negative, we make it positive. And the reason we use this is when we are comparing distances or temperatures or things like that. For example, say we're going to look at Moscow, Russia. Now, some quick facts about Moscow, Russia are that a typical summer temperature is around 23 degrees. Now, this is 20 degrees Celsius. Oops, and I should probably spell summer right. That works close enough. This is math class, not humanities. And a typical winter value, it's around negative 10 degrees Celsius. Now, the question is, during summer or winter, is it closer to the freezing point of water? Now, I need to know the freezing point of water in the Celsius scale is 0 degrees Celsius. So the question is, what's closer, 23 or 10? Well, this is kind of obvious, but it's important to look at it from a number line perspective to see why we would use a absolute value. So if I have my 0, I have 10, I have 20, I have 30, I have negative 10, and negative 20. Oops, negative 20. My summer is going to be right here. I can put a big S. My winter is right here at a negative 10. And my question is, which is closer to 0? Now, it seems obvious that this is 10 units away, and this is 23 units away, right? Well, notice that the distance away from 0 is actually just the absolute value of these two numbers. So if I take the absolute value of 23 and negative 10, it tells me the distance from my 0 point. And that makes it very easy for me to compare. So my summer distance is 23 degrees away, and my winter distance is only 10 degrees away. So then I know that in winter, it's closer to freezing than in summer. Now, a lot of this seems like it would be pretty obvious to do in your head, and maybe it might be. But we use this a lot if we're writing code or if we're kind of using a computer program that needs to use distance calculations like this without needing to ask every time if it makes sense. Now, in this section, when you're doing your homework, you're just going to be writing the opposites of numbers and the absolute values. So again, real quick, if you feel like you get it, go on. But if I'm going to take the absolute value of a couple numbers, let's take -3, 5, 100, and -7. All that happens is I lose my negative if I have one. Oops, I was totally off the screen. And if I'm taking my opposite, all I do is switch my negative and positive depending on where I'm going. So say I have 16, -23, 54, and -111. I would go to -16, 23, -54, and 111. Make sense? Okay, good luck.